In this video, I just want to show an example of how we may need to use the sum or difference identity when solving an equation. The idea here is that we may need to use any of our identities when solving an equation. You may be handed some mess on one side of your equation and asked to solve when that's equal to a particular value, or maybe some other trig function. And so to solve the equation, we have to be able to clean up the mess. This could involve any of our identities. So here's just one example using sum and difference identities. So suppose we are asked to solve this equation by finding all real solutions. So we're looking for the general solution to solve this guy. And up here, I wrote the sum or difference identities for both sine and cosine. So hopefully, if you were doing this problem and you encountered this, your spidey senses would go off a little bit and you'd start to say, sine, cosine, cosine, sine. That sounds like an identity. That looks like the sum or difference identity for the sine function. So then it's just simply a matter of taking a look at the sign in between to determine what sign I should use when I clean this up. So looking at that identity, we should be able to rewrite all of this as sine of angle x plus angle 2x, and all of that has to equal 1. So that means sine of 3x equals 1. And now this looks like a doable equation, something we've encountered before, just a multiple angle equation. Okay, and let's solve this in radians. All right, so the identity part is done. Now we just solve our equation. And I can identify 1 on my unit circle. I know that sine is going to be 1 up here at the angle pi over 2. That's the only place sine is 1. So this means that angle 3x, whatever it is, it's got to equal pi over 2. It's got to face that way, or it could be anybody that's coterminal, right? As long as it's pointing that direction, it's good. So pi over 2 is a valid answer, but so is anybody coterminal to pi over 2. All right, so to solve this equation for x, we'll just multiply everything through by 1/3. That gives us x all by itself on the left. And distributing the third, we would get pi over 6 plus 2 pi over 3k, where k is some integer. You could spell it out or use that notation to say that k belongs to the set of integers. Okay, so again, this was just a brief example to show that there will be times where we need to use identities to solve equations. I'm sure you've already countered quite a few of that, but here's a specific example using sum and difference identity. Keep up the good work.